Today we're going to tackle boat in the river word problems. These are uniform motion problems where the speed of the vehicle is being influenced by an outside force. The ones we're going to do today are all going to be boats in a river, but they could also be airplanes with the wind blowing on the plane faster or slower, that kind of stuff. The only difference between these and uniform motion problems that we've already seen is how the rate is determined. And what we need are specifically the rate of the boat in still water that is given to you this way. The boat could go 50 miles per hour in still water. Or it might say the boat can go 50 miles per hour on a lake. That means still water. Okay, so we're assuming a lake is not moving. Alright, no current. The other thing we need is the rate of the current. If they give those to you, identify them as what they are. If they don't, use variables to represent them. I usually use the letter B to represent the speed of the boat and C for the speed of the current, if I have to use variables. Okay? And then we're going to establish two specific rates. When you start seeing a boat and river problem, you have two categories. It's not the people in the vehicles or whatever. It's not boat, common motorcycle, or anything weird like that, like we've seen in these other ones. It's going to be upstream and downstream. Upstream is against the water, so it's the still water speed minus the current speed. Because if you are going this way and the current's going that way, it's slowing you down, so you subtract the current from the speed of the boat. If you're going downstream, that means you're going with the current, this still water speed plus the current. So if you're going that way and the current's going that way, the current's pushing you faster than you normally go. That's how the rates are established. And again, you're either going to use variables or specific numbers for those things. The times and distances are done the same way as normal. The boat could go 50 miles upstream in 2 hours less than it took to go 500 miles downstream. Something like that. Alright? So 2 hours less, T minus 2, right? The total trip took 10 hours. T and 10 minus T. So times are like normal, and the distances are going to be given to you usually in these problems. Alright, so you're only allowed to use two variables, so make sure you don't go beyond that, and make two equations, RT equals D, solve using advanced substitution, answer the questions. So let's tackle one, see how it works, and again, this is just kind of a guideline for how to do it. Hopefully that's enough to give you some clues. So Robert and Clay can go 60 miles downstream. Where's that? That bothers me that there's a dot on the board there. Cover that. All right, now it's gone. Wow. Robert and Clay go 60 miles downstream at the same time it took them to go 20 miles upstream. If the speed of their boat was 8 miles per hour in still water, what was the speed of the current and what were their times? So, if we focus first of all on, again, speed of the boat in still water and speed of the current. So, the speed of their boat was 8 miles per hour in still water. Alright, so I'm going to write down over here, in fact I'll put it right up above this, B equals 8 miles per hour. Do not put 8 miles per hour in the rate boxes. Establish the speed of the boat in still water and the speed of the current before you start filling the boxes down here. It says, what was the speed of the current, which implies we don't know that, right? So I'm going to say C equals current. Those are the two things influencing the speed of the boat in this problem. Anytime you do it, you start seeing boats going in water, you start seeing the words upstream or downstream showing up. These are going to be our categories. It's always boat minus current for upstream, so 8 minus C for upstream, and boat plus current for downstream. Very important. You subtract the current away on the upstream, you add the current on the downstream. And the boat speed goes in front, the current speed goes in back. Next, we fill in times and distances in the same time. Does it tell us how much time it took?
No.
No. So we don't know it, but they're the same, so time is T, time is T. Okay, if we take a look then at distance, they could go 60 miles downstream. So downstream distance is 60 miles. In the same time it took them to go 20 miles upstream. So 20 miles is the distance upstream. So you fill in all the boxes, you get to use two variables, and then it's just rate times time equals distance at this point. 8 minus c is the rate times time equals 20, so that's 8t minus ct is equal to 20. Rate times time equals distance for this one also. 8 plus c times t equals 60, so 8t plus ct is equal to 60. And we create this system of equations that we've already seen this happen, like, I don't know, about a week ago, right? We saw a problem sort of like this. B, T sub D, they look like that, right? Remember those? And if we're going to use elimination, which is preferable, we want to get rid of the one with more variables in it. So notice minus CT and plus CT is ready to go, right? So if I add the two equations together, 8t plus 8t is 16t. 20 plus 60 is 80. We divide both sides by 16, we get t is equal to 5. So that tells me exactly how many hours they traveled, right?
Yeah.
The question was, what was the speed of their current and what were their times? The times, of course, 5 hours both because they were the same time. So 5 hours is one of the answers. The other question they ask us is how fast was the current? Okay, so if I know the time equals 5, and I know rate times time equals distance, right? What number times 5 equals 20?
4.
What number times 5 equals 60?
12.
12. So either 8 plus c equals 12 or 8 minus c equals 4. What does c equal? What?
4.
4, right? 4 miles per hour. That M is kind of...
So the current was the same for both?
Well, it's the same river.
Oh, okay.
Yep, it should be. Yep.
Okay.
But again, one way we're going upstream, so the current's pushing us slower, right? So if this boat, all they can do is 8 miles an hour in still water, and all of a sudden you got a 4 mile an hour current pushing you slower. And then the other way around is if you got 8 miles an hour top speed, but then that current's pushing you 4 miles per hour faster. So the boat's going faster or slower depending on the current, but the current itself is 4 miles an hour because it's not going to change.